Hello everyone, this is Marshall Lamb from the National Peanut Research Laboratory in Dawson, Georgia. Today I want to talk to you about sustainability of U.S. peanut production. We'll be pulling data from different sources to give you the picture of where we've been and where we're at. Joining me today is Casey Cox from the Flint River Soil and Water Conservation District and Longleaf Ridge Farms. Also Ron Sorensen and Chris Butts from our lab. So why does sustainability matter? We hear about it within the peanut industry, we read about it in other crops and other manufacturing methods, but it's not about us, it's about the consumer and what the consumer wants to see when they are making a decision to purchase a product. And in order to do that, we have to understand the consumers. So this chart looks at the age brackets for generations in the United States. We've got the Gen Zs, which are 22 and under. We've got the Millennials, which are 23 years of age up to 38. And we've got the Gen Xs, which are 39 to 54. And then the Baby Boomers, which are 55 to 73. And each of these groups have different purchase patterns, and we have to address that. If you look at the total population in the U.S. being over 330 million people, it's interesting to note that the Gen Zs and Millennials now comprise about half of the United States population. So they've grown rapidly and they're accumulating purchasing power, which is very important to us as well. The Millennials and Gen Zs are twice as likely to purchase in a way that will reduce their impact on the environment. The sentiment, there was a quote that I found, consumer sentiment is shifting toward healthy for me, healthy for the world. And what's interesting too, the bottom bullet, is that age is not the only factor, because now Nielson came out with a study that showed that 60% of all Americans fall into the sustainable mainstream category, which means some of the baby boomers are starting to also move up in their thinking towards sustainable purchase. So for today, here's some of the data that we're going to be pulling together. The first one comes from a United Nations study, UNESCO, that focused on water use of all crops around the world and in the United States. And it went from 1996 to 2005. The other we're going to pull in is the USDA Ag-Resource Management Survey. It was done in 1999, 2004, and 2013. It looked at water use and production practices, but it's only done in every 5-year or more increments, and it's hard to predict, so it's not a consistent data set to use. American Peanut Council has been very active in the field to market field print calculator as well. And then some more data comes from a nationwide survey of peanut producers from 2016 to 2019 from the Flint River Soil and Water Conservation District. So today we only have time to cover some very small snapshots of these really, really big data sets. So we're going to highlight a few things. This is the UNESCO data, looking at water use in peanut, almond, walnuts, and pistachios. They separated their water into different categories of being green, blue, and gray. Green being rainwater, which is a given to us. Blue is irrigation, whether from surface or groundwater sources. And gray water is the amount of water required to remove or disperse pollutants, mainly nitrogen. And as you can see, if we look at just the blue and the gray, since those are ones we can control, peanuts use about 4.7 gallons per ounce to produce. That's a very favorable footprint when you look at the fact that in almonds, it takes 80 gallons to produce an ounce of almonds, walnuts around 73 to 74 gallons per ounce, and pistachios, which take about 19 gallons per ounce to produce. So we're in a great place as far as our water footprint right here, and we'll look at even further improvements in that in a little bit. Well, here it is. If we look at peanut irrigation water use over time, You can see the UNESCO is on the far left at the 4.71 that we just talked about. And then in 1999, the ARMS data set took a survey, and they showed that U.S. Water use, this is again blue and gray, was 5.2, and then in 2004 it dropped to 4.2, and then in 2013 it dropped down to 3.1. So nice improvements over time within the ARMS data set. And then in 2016, 17, and 18, we have the Flint River Soil and Water Conservation District data, where we were at 2.8, roughly again 2.8, and then 2018 at 2.7 gallons per ounce. So we're showing a continual improvement in this number on water use efficiency, but one of the keys to moving this forward is improved high yield, drought tolerant varieties that will help us with our water footprint. Dr. Holbrook covered a lot of this in his opening symposia talk, and this is work that we really need to continue and really need to support as we move forward. This is fertilizer usage, which is always important. And what we're looking at here is data from the ARMS data set and the Flint River Soil and Water Conservation District. And in this, over in this left part, this is total NP and K by year in 2019, 2004, 2013, and then from the surveys compiled. And as you can see, total NP and K in 1999 was roughly 0.04 pounds per pound of peanuts. That dropped in 2004 to 0.03, and then significantly dropped in 13, and the data set for the 2016-2018 period down to 0.014 and 0.012. And these are significant improvements. Now, this breaks out the nitrogen, phosphorus, and potassium fertilizers. We won't go into those individually, but you can see the same trends. Now, I think what happened here was we did have an acreage shift within the United States between these periods, but also, y'all, the bottom line is great research and great extension efforts showing producers they don't have to put the additional NP and K on peanuts, and it's really paying off for it. Some other indicators real quick, and this comes from the Flint River Soil and Water Conservation District surveys in 2016 through 18. And these are other indicators that help us on our footprints. One is rotation. It showed that irrigated peanuts are 2.24 on average years out of peanuts. So we've got peanuts and then cotton, corn, or whatever the rotation partner is before we come back into peanuts. Very good rotations. The non-irrigated rotations were at roughly 2 years. So we're practicing good rotations in irrigated and non-irrigated. 77% of the producers leave the peanut hay back on the field. This is a positive for us as well because it has nitrogen, it has other fertilizers in the peanut hay that help rebuild the soil and also helps us some with erosion control. Use of precision technology came in at 94%. I thought this was an amazing number, but most growers, well, 90-something% of growers are utilizing precision technology, and it's paying off on our sustainability footprint where we're putting precise amounts of everything that we need in crop production at the right level, at the right place. 83% of the growers use in-gun shutoffs, so we're not applying water to non-target areas. It's only on the crop that we need it, and that is very important as well. 100% follow extension guidelines, and that is a very impressive number. It's not surprising because the extension services we have in the peanut producing areas are so good, so well respected by growers that growers follow what they say. 86% follow nutrient management plans. Thought that was really good. On a disappointing note, under 30% use irrigation scheduling programs. Maybe that is a way, partnering with NRCS and others, that maybe we can get that number improved and start getting growers starting to use more irrigation scheduling. 78% utilize cover crops within their production system. This was a general question, and they utilize cover crops within their production system. Not always on peanuts, but on the rotation partners. And that's evidenced by the last one down on the bottom, where we look at only 28% use conservation tillage in peanuts, compared to 72% use conventional or clean tillage. There again offers some opportunities for growers to move from conventional tillage to more conservation tillage in the future. Now, we're sustainable because of a lot of different factors. Some of it are inherent properties of the peanut. Our industry and research groups have been very proactive in this. But we have a crop that is deep rooting and wide rooting. It has an indeterminate flowering pattern, which will wait on a rainfall in non-irrigated production. When we get it, we start flowering and make peanuts. Leaf thickness, leaf structure, canopy structure, foliage biomass relative to root biomass, these were ideas brought forward by, I think, Dr. Booty. And we know we're water use efficient. Being a legume, we don't require nitrogen fertilizers to be added, and we're very efficient at using fertilizers. GPS, we saw where we've moved to, and that I think is helping. Irrigation improvements, advanced scheduling, but also going from high pressure to mid pressure to low pressure systems help. And just information delivery back to our extension services. And a proactive commitment by our industry at all levels to get this done. Genetics, pest management, that's research, y'all, and that's one of our keys. Majority of peanuts are grown in areas that get greater than 50 inches of rainfall per year, and that helps because we are growing an annual crop instead of a perennial crop like we saw earlier, and we plant and we produce the crop for 140 to 150 days, and then we no longer have to irrigate, and that helps tremendously. And finally, crop rotations and extremely good yields that we've seen in the last several years help us on our sustainable footprint. So, to wrap it up, sustainability is one of many factors that affect a purchase decision from a consumer. And we have a great story to tell, and we got to get it out to them. We've seen increases in consumption, both long-term trends and during the recent pandemic, that shows the power of the peanut. And as Don Kaler adds in his email footer, sent from my peanut butter jar. And remember, peanuts and peanut butter are delicious, nutritious, affordable, and sustainable, so go spread some love today. And thanks to our APRES leadership for having the meeting this year, though virtual. And I look forward to seeing everyone next year.